Hi, this is Mrs. Kidman, and in this video, we're going to be talking about how we can apply standard form of quadratic functions to the real world. So one of the easiest examples of when we see quadratic functions in the real world is actually when we're dealing with bridges. A lot of those cable bridges that we see, whether it's this one in Michigan, whether it's the Tacoma Narrows up in Washington State, all of these cable bridges that we see end up having these curves, these parabolic curves that we can represent using a quadratic. And so all the time, structural engineers that are building these bridges end up using these quadratic functions all the time to figure out how low that needs to hang, how high it's going to be above the water, things like that. So what we're going to do is we are going to look at how they figure things out. So in this case, what we're looking at is a suspension cable between the two towers of the Mackinac Bridge in Michigan, and they form a parabola that can be modeled by this quadratic formula, this quadratic equation here, where x and y are measured in feet. So what we want to know is what is the height of this cable above the water at its lowest point. Now, this phrase lowest point here should clue us in to what we're looking for is the minimum of our vertex. And in our previous video, when we talked about maximums and minimums, remember we said that our minimum is another way of saying our vertex. So what this wants to know is what is the height or the y value. So our height is our y value. What is the y value of our minimum or our vertex? In order to find that y value, we are going to have to find our whole vertex. So remember, to calculate our vertex, we want to find the axis of symmetry first. And our axis of symmetry is negative b over 2a. So get out a calculator for this because we do have some decimals. So when we substitute this negative b and this 2a into our formula here, we end up getting a negative 0.37 over 2 times 0.0000. That's right, that was 4 zeros. 98. So now that we simplify this, we get 0.03 over, and as I type that in, I have 0.1234 zeros, 98. And we multiply that by 2, and we end up getting 0.00030 zeros, 196. And I want to simplify that. So as I type that in, 0.3 divided by 0.000196, well, that is going to give us x equals 1,530.6 feet. And that makes sense, right? Our lowest point here on our vertex looks like it probably falls somewhere in here. And that's between 1,500 and 2,000. And that's exactly what we got. So to find our vertex or our minimum, we need to substitute that value back into our original function. So that's what we're going to do. I've got 0.000098 times this 1530.6 squared minus 0.37 times 1530.6 plus 552. And whatever this number gives us, that's going to be the height of the cable above the water at its lowest point. So we want to square this. 1530.6 squared is going to be 2,342,773 point change. And I want to multiply that by 0.000098. And that gives me 229.6 roughly. And then this next part, 1530.6 times negative 0.37 gives us a negative 566.322. And then we want to add 552. So as we add up all these numbers, 229.6 plus 229.6 minus 566.322 plus 552, that ends up giving us 215 and some change feet. So what is the height above the water at the lowest point? Well, that's going to be 215 feet-ish. Okay, give or take a little bit, but 215 feet. And all we did is we just had to find that vertex again. So remember, our vertex is crucial in doing this. Now, what I want you to do is look at, not this problem, sorry. I want to look at this problem here. This one's all about the two towers on the Tacoma Narrows Bridge. This one's going to be exactly the same, but notice how it's modeled by a different equation. And what we want to figure out is what is the height of the cable above the water at its lowest point. So I want you to figure this one out on your own. Go ahead and pause the video. Remember, we're looking for the lowest point or the minimum. So figure out what is the height of the cable or the y value for our minimum of our function. When you've got that, unpause the video and we'll go over it together. Okay, hopefully you've had a chance to go over this problem on your own. Here I drew a little picture of what we're looking at. So here's our bridge, and they're asking what is the lowest point of that cable above our water here. And that cable is represented by this function of 0.00016x squared minus 0.46x plus 507. We're looking for the lowest point, so that's our minimum or our vertex, and we're looking for that for the height of the cable above the water. So that means I'm looking for the y value of my vertex. So to find that, I first have to find my axis of symmetry, and that's going to be negative b over 2a. And as I calculated that out, my axis of symmetry said that my x value for my vertex is going to end up equaling 1,437.5 feet. Now I want to figure out the y value, not the x value. So in order to find that y value, what I'm going to do is I'm going to substitute my x value back into my equation or my function that represents this cable here and figure out what is that y value. So as I plug it in, I simplify it, and I ended up getting 176 and some change feet. Okay, so how high is it above the water? About 176 feet above the water. And that is how we would apply this. So we want to look for either a local maximum or a local minimum, see what it says, see if it's addressing our vertex, and then find that value using our vertex. And that is how we would apply the quadratic function, especially one in standard form in the real world. If you have any questions, feel free to reach out and we can go over it together.